Hi students, welcome back into my channel. In this video, I will discuss and explain simple harmonic motion, a necessary material for those students who learn deeply of physics. Okay, first of all, I will begin with the understanding of restoring force, especially how we calculate the restoring force of a pendulum, and as well the restoring force of a spring. The restoring force, the formula of spring restoring force is so very simple because the formula is F equals minus K times Y. But for restoring force of a pendulum, of course, equals F equals mg sine theta. So how we find that formula? I'm going to show you how we find that formula through this simulation. Okay. But firstly, I will show you the understanding of restoring force. Okay. This is the pendulum on its normal position. If I bring this pendulum on this position, this pendulum will swing until the maximum position, like this. Okay. And we can measure the period, and as well we can measure the frequency of this pendulum. But now I'm going to show you how we calculate, how we find the formula of restoring force. But you have to understand the restoring force on a pendulum. Okay. The restoring force of this pendulum, I'm going to show you when this pendulum moves, it moves back into its normal position. It needs force, and its force name is restoring force. So restoring force, this pendulum needs when it will back move, return back into its normal position. All right. Now I'm gonna show you how we find through this triangle. I'm gonna create a right angle triangle. Okay, through this straight line. And if this is right angle triangle, and if the right angle on this angle, so if this straight line is y-axis, and this is x-axis, okay, and this is a. As you know, to measuring this pendulum weight, we need this formula, that weight equals m times g. M for mass, g for gravitational force. All right. Mathematically, that sine theta, if this is theta, this angle is theta, sine theta equals y, equals y over a. Sorry, y over a. Yeah. I mean y here over a. Okay. So it means y equal a sine theta. Okay. If A is the restoring force, because this is the restoring force direction, okay, so we can writing that F or restoring force equals, and if A is M times G, it becomes F equals M times G sine theta. Yeah, so this is the formula of restoring force when you will calculate the restoring force of a pendulum. Okay, now on a spring, uh, the spring you can push or pull, okay, but it is the normal position, okay, or the equilibrium position. If you push this spring, okay, uh, yeah, it needs force, okay, it needs force to return to return to equilibrium position, to its normal position. And the force it needs to return to its normal position we call as the restoring force, or the symbol of F. Okay, and look, the direction of the restoring force, the opposite of the force when you pull the spring. Okay, now I'm going to show you uh, that uh, yeah, when you pull the spring, okay, and you okay, I will set in normal position like this, yeah, in equilibrium position. Now I'm going to show you when you pull the spring. When you pull the spring, look these directions, yeah, as well, opposite with the force when you pull uh, the spring. When you pull the spring, actually the direction to the right side, and the directions of this force, of the restoring force, is always opposite with uh, your direction. And the direction to, and this force, this force we call as the restoring force. So the restoring force of spring is the force when a spring, when a spring will move back, will return back into its normal positions or its equilibrium position. So that's the understanding of restoring force. Now, how we calculate the restoring force? Through this formula, that negative K times Y. Why negative K? Because uh, always the directions opposite with your direction. When you pull, this directions opposite with your pull force. When you push, and as well, the restoring force opposite with your push direction. So that's why the formula becomes negative k times y. Which y is the displacement. Okay, from displacement from initial point into the last point when you push or when you pull. Hi, students. As we continue our lesson regarding simple harmonic motion or SHM. A simple harmonic motion is defined as a motion in which the restoring force, okay. So later we are going to deeply discuss regarding restoring force. So again, SHM is defined as motion in which the restoring force is directly proportional to the displacement of the body from its mean position. And the periodic motions of particles along the same path is called oscillations or vibrations. Okay. Also, we are going to learning deeply regarding oscillation and vibrations. But I will provide this video especially for those students who want to learn deeply regarding this material. First, restoring force in simple harmonic motion. There are two restoring force in simple harmonic motion because we can learn, we can calculate simple harmonic motion restoring force through spring and as well pendulum. So restoring force on springs F equals ky uh, if we calculate in scalar notation, and F equals minus ky for vector notation, which k equals spring constant with unit Newton per meter, and y is deviations with unit meters. And then for resonant force in a simple pendulum, the formula F equals mg sine theta, for m is mass with unit kg, kilograms, and g for gravitational force with unit Newton per kilograms. As you know that for the Earth gravitational force, of course, 10 Newton per kilograms or 9.8 Newton per kilograms. Right. Two, period and frequency. The period of a simple harmonic motions is the time it takes for an object to complete one full cycle. Okay, so frequency is the number of vibrations or oscillations made in 1 second. So the formula of frequency and periods to calculate frequency, this is the formula F equals 1 over T, and as well for T equals 1 over F. I think this formula are familiar for those students who will learn this material, simple harmonic motion. Next, 3. The two most common simple harmonic motions experiments are, there are two formulas. In a simple pendulum swing, if the length of the string is L, then the period is, so if you calculate, if you would like to calculate period in simple pendulum swing, you could use this formula, T equals to pi times square root L over G, which G equals, G is gravitational force, okay? Yeah, G gravitational force. Okay, G gravitational force and L for length of the string. Okay. Next, for A spring with spring constant K, which vibrates due to a lot of mass, and the period of vibrations becomes T equals to pi times square root m over K. Recall that for recall that K is spring constant while m for mass. For the next formulas, deviation in a simple harmonic motion, the formula is y equals a sine omega t, or y equals a times sine 2 pi ft. It's y for deviation, the unit in meters, a for amplitude, meter as well unit. Omega is angular velocity, the unit is radian per second. F for frequency, unit hertz. And t is time taken, unit. The unit is in second. The next formula, if at the initial moment the object is in position theta 0, then this formula, okay, the deviation formula becomes y equals a sine omega t plus theta 0, or y equals a sine 2 pi f t plus theta 0. If the angle omega t plus theta 0, this angle is called the phase angle or theta. So we can found theta equals omega t plus theta 0, or theta equals 2 pi time over 2 pi times over period plus theta 0, yeah, plus the angle, yeah, theta 0. Okay. And phi is called the vibration phase, and delta phi is called the phase difference. Okay. So we can arrange this formula. Theta equals 2 pi times in brackets times over periods plus theta 0 over 2 pi equals 2 pi, 2 times pi times phi, which phi equals this one in brackets times over period plus theta 0 over 2 pi. So delta phi equals phi 2 minus phi 1, or delta phi equals the time 2 minus times 1 over period. Next, for the next formula, speed in simple harmonic motion, how we calculate speed or velocity in a simple harmonic motion. For an object that at the initial moment theta 0 equals 0, the speed is v equals dy over dt equals d over dt of a sine omega t. So velocity equals omega a cosine omega t. Cosine because the derivative of sine equals cosine omega t. Derivative of this term, a sine omega t equals omega a cosine omega 3. Okay. Why? Because v equals dy over dt equals d over dt. The derivative of this is term a sine omega t plus theta 0. So the derivative becomes omega a cosine omega t plus theta 0. Then if the speed value in v, okay, will be maximum when cos omega t equals 1. So the maximum speed or the maximum velocity we can calculate through this formula, Vm or V maximum, or the maximum velocity equals omega times A. And the speed of the object at any position y is Vy equals omega times square root A squared minus y squared. And number 6, acceleration in a simple harmonic motion for an object that at the initial moment theta 0 equals 0, the velocity or the speed is like this. A equals dv over dt equals d over dt of a cos omega t, and the derivative of a cosine omega 3 omega t equals minus, you know that derivative of cosine is sine, is negative sine. So derivative of a cosine omega t equals minus omega squared a sine omega t, or it becomes negative omega squared y. Yeah, as you know that this is we have state as y. Yeah, just now. Okay, so the acceleration value will be maximum when cosine omega t equals 1. So the maximum acceleration formula is this one. For the maximum acceleration equals omega squared a. And the direction, because this factor, you know, that velocity and acceleration as well is the vector quantity. So it has direction. So direction of acceleration is always same as the direction of the restoring force. Okay, it's important for us to memorize this. Next, for 7, energy, how we calculate energy in a simple harmonic motion. There are 2 types of energy, kinetic energy and potential energy. Now, for the kinetic energy of an object that performs simple harmonic motion, for example, a spring, is AK equals kinetic energy equals half mv squared, or kinetic energy equals half m omega squared a squared cosine squared omega t. Since k equals m omega squared, we obtain, or we can determine that the kinetic energy equals a half k a squared cosine squared omega t. Right. For the elastic potential energy stored in the spring for its extension, Y is 1 for potential energy equals half k y squared, or potential energy equals uh, half k a squared sine squared omega t. As you know that y equals sine omega t. Or we can extend this formula becomes potential energy equals half m omega squared a squared sine squared omega t. Okay, why? Because k uh, is constant. Okay, uh, for mass. Now, if friction is neglected, the total energy of mechanical energy in spring vibration is mechanical energy. As you know, mechanical energy is the additional of potential energy and kinetic energy. So En equals EP plus AK equals half Ka squared times sine squared omega t plus cosine squared omega t. In mathematics, these terms equals 1. Now, this formula becomes half ky squared plus half mv squared. Or we can simplify becomes half k a squared. So you may using this formula for how to find energy, mechanical energy. All right, we are going to continue to discuss several question and answer about this topic. Okay, let's start to discuss several questions and answer of simple harmonic motion. Number one, a simple swing has a rope length of 40 centimeters with a weight of 100 grams. Determine the magnitude of the restoring force if the object is moved 4 centimeters and the accelerations due to gravity at the place is 10 meter per second square. Right. Firstly, we have to identify uh, uh, this problem that L, yeah, L equals 40 centimeters, but we have to convert becomes meters because the unit of length is in meters. So L, yeah, sorry, but I use this. Okay, okay, L in meters. So L equals uh, 4, yeah, 40 centimeters. I mean, or if we convert into meters, it becomes 0.04 meters. Okay, that's for L. And after that, weight, okay, or I think this is mass. Yeah, because weight equals m times gravitational force. So I'm going to identify this as mass. Okay. Mass equals 100 grams. And as well, we have to convert into kilograms. It's going to be 0.1 kilograms. Right? What else? And then the object is moved 4 centimeters. Okay. It means y equals, okay, 4 centimeters. and as well convert into meters, maybe 0.04 meters. Okay. Uh, sorry, length equals 0.4 because 40 centimeters. And yeah, gravitational force, of course, 10 meters per second. Now we're going to calculate F or force. Okay. Next, force. Okay. This pendulum, it means based on the formula that force equals F, equals M, yeah, yeah, mg sine theta. Okay. M times G times sine theta. Okay. So it becomes M 0.1 times G 10 sine sine theta. We can convert to y over L. Okay. Sorry. Y over L. Okay. And it becomes 0.1. It's going to be, yeah, 1. 1 times y 0.04. Okay. Over 0.4. Okay. Over L. Okay. And it becomes, if you divide it, becomes 0.1. Yeah. 0.1 newtons. Okay. And the direction, the direction is the opposite. So actually, we can give negative, but negative is just for the direction. Yeah. So the restoring force, 0.1 newtons, and direction, of course, the opposite or negative. Okay. Number two, a 20 centimeter spring has spring constant 400 Newton per meters. Calculate, calculate the force required to stretch, become the full length spring 24 centimeters. Okay. So for stretching, yeah, 20 centimeters minus 20. So the stretching mm, was 4 centimeters. 4 centimeters convert into meters equals 0.04 meters. Okay. Then, yeah, F equals the force F equals, yeah, sorry, F equals next. It means 400 Newton per meter. Okay, this is the spring constant or K. Okay, actually K equals 400. Okay, a Newton per meter, sorry. Meter. Okay. So this is k times y. Yeah. Okay. X. F equals k times y. Okay. We calculate in scalar. If it means 400 times 0.04. Okay, equals, I'm going to calculate, yeah, 16. Okay, 16 newtons. Okay, yeah. Okay, next for number 3, a spring with a force constant 1,500 Newton per meters is loaded vertically with a mass that extends the spring to 8 centimeters. Find the magnitude of the spring force. Yeah, I've seen this simple calculation. Just force. Okay, force equals. Yeah, of course, 1,500 Newton per meters times y how much just now? 8 centimeters. What we have to convert 8 centimeters to meters becomes 0.08. Okay, 0.08 meters. Okay, so it's gonna be how much it is? Let me calculate. 0.0 0.08 times 1,500 equals, yeah, 120 newtons. Okay. Number 4, an object performs simple harmonic motions along the y-axis. The definition changes with times according to the equation y equals 4 sine t times pi plus pi over 4, with y in meters and t in seconds. Okay, find the amplitude, frequency, and period of its motion. All right. So yeah, y equals 4 sine t times pi plus a quarter pi. Okay. Now we are going to determine amplitude, frequency, and periods of its motion. Okay. Okay. Y, as you know, the formulas that y, the equation formulas a sine a sine omega t plus theta 0. Okay, you may evaluate this formula from our previous lesson, or my previous explanations on the same paper just now. So if A equals 4 meters, it's 1, 4 meters. Yeah. Okay, so A sine omega t plus theta 0. If you compare, yeah, if you compare this with this equation, A, okay, and it's on 4, okay. So A equals 4. Okay, so the amplitude equals 4. Okay. Next, amplitude 4 and frequency. As you know, for the formula 2 pi f equals pi. If you divide pi over pi equals 1. So 2f equals 1 and f equals half. Okay. Unit hertz, the unit in hertz. Okay. This for frequency, and then for period, as you know, through the formula just now, we learned that T equals 1 over F, or 1 over half a half hertz. It's going to be 2 seconds. Okay. Yeah, that's A. And next B. For question B. Calculate the speed and accelerations of the object with respect to time. We're going to determine velocity. Yeah, because speed is scalar, where velocity is vector quantity because it has direction. So for as you know that for velocity is derivative, okay, dy of dy over dt, okay, dy, the derivative for t, okay, and it becomes a times omega. Why this? Sorry. A times omega cos, yeah, cosine omega t plus theta 0. Okay. Yeah, we have learned this derivative, this formula. So it's gonna be 4 theta because A equals 4. Yeah, and yeah, 4 theta. Okay, cos, yeah, cosine uh, pi t. Okay, pi t plus pi over 4 and unit meter per second. Okay, equals. Yeah, that's the, yeah, this is velocity. So the velocity for pi cosine pi t plus pi over 4, or a quarter pi meter per second. And yeah, we cannot simplify this. Now, regarding acceleration, because we are going to continue to calculate to determine acceleration. As you know, the acceleration is the second derivative of this equation. Okay, or the derivative of velocity. So dt over dt, and derivative to t. And then we are going to uh, to find the derivative of this velocity of this term, a omega cosine omega t plus uh, theta zero. So uh, if we find the derivative of this term, it becomes, yeah, derivative of cosine equals is negative, yeah, negative sign. So it becomes negative 4, negative a, sorry, negative a equals a omega squared sine a omega t plus theta zero. Okay. Of course, the unit meter per second. So as you know that a equals 4 because of this amplitude 4, so negative 4 pi squared and sine, yeah, sine pi t, yeah, plus a quarter pi meter per second squared because acceleration. C. We are going to answer part C, 4C. Okay. When t equals 1 second, it means y equals, okay, 4 sine, okay, 4 sine pi t plus a quarter pi, okay, equals, yeah, 4 sine, this is 180, yeah, 4 sine, better I use this, equals 4 sine 180 times 1 equals 180 plus 45. Okay. Why 45? Because if 180 divided by 4 equals 45. So it means this sine 4 sine 225. Okay. 225, 4 times, okay, sine 225 minus half square root 2. It becomes negative 2 square root 2. Okay. And the unit, yeah, meters. Okay. Okay. It means to determine velocity or speed. Speed equals derivative of y, of this one. It becomes 4 pi cosine cosine pi t plus a quarter pi. And if we calculate, um, yeah, 4 becomes 4, 4 pi, I mean 4 pi, 4 pi cosine 180 plus 45. Okay, yeah, pi here. Okay, okay, 4 pi cosine 180 plus 45. So it means 4 pi times, so that cosine 225 minus half square root 2. Okay, so it becomes minus 2 pi minus 2 pi square root 2. Okay, yeah, velocity it means meter per second. And then after that, acceleration. Acceleration is the derivative of 4 pi cosine pi t plus quarter pi. It's going to be negative 4 pi squared sine a sine pi times t plus 1/4 pi, okay, equals 4 pi squared sine 180 plus 45 sine 225. It becomes 4 pi squared, minus, I mean, minus here and minus times minus half square root 2. Okay, equals, yeah, positive 2. 2 pi squared square root 2. Yeah, right, that is C. And D, next. The question is determine the maximum speed and accelerations of the object. The maximum speed we can calculate through this formula, the maximum speed equals omega times a 4 pi meter per second. While for acceleration maximum, yeah, for here acceleration maximum, okay, for acceleration maximum minus a times omega squared. Okay, It's going to be -4 pi squared. And the unit meter per second squared. Okay. And what else? E. Okay. E. E we can determine the displacement of the object between t equals 0 and t equals 1. Okay. Okay. Wait, when t equals 1 second, okay. When t equals 1 second, it means y, okay, y1 equals -2 square root 2 meters. Okay, when t equal 1 second. Yeah, so y equals yeah. Sorry, not y. Well, not y1. What y equals 4 sine okay, pi t plus a quarter pi. Okay, so y 0 when t equals 0. Okay, so when t equals 0, t equals 0, y equals 4 sine pi times 0. Okay, pi times 0 plus a quarter pi equals 4 sine 45 degrees, and then y equals 4 times half square root 2, because sine 45 is a half square root 2. So y equals, if multiply, 2 square root 2. Yeah. So delta y equals y1 minus y0 was okay y1 -2 square root 2 okay. And y0 this one 2 square root 2. Okay, so it's gonna be -4 square root 2 meters. Okay, all right, this and number 5, a simple harmonic motion has an amplitude a equals 6 centimeters. So we have to convert this. What is the vibration deviations when the speed is 1/3 times the maximum speed. Okay, for the next, and then yeah, y equals a sine omega t. Okay, so it means the velocity, for velocity, derivative of this term becomes a times omega cosine omega t. Okay, so it means 1/3. Yeah, because 1/3 a 1/3 times t max. Yeah, velocity maximum. So 1/3 times a omega. Okay. Uh, Now cos omega, okay, cosine omega t1. Sorry, omega t 1/3. Okay. And then sine squared omega t plus cosine squared omega t equals 1. This is trigonometric identity. Then sine squared omega t, as you know, that this is negative 1/3. So squared was 1. And it means sine, yeah, sine 1, sine squared omega t equals 1 minus 1 ninth. Okay. Equals 1 minus 1/3 squared. It means 8 over 9. Yeah. So sine omega t square root 8 over 9. And we can simplify, becomes square root 8 over square root 9. Then equals square root 4 times square root 2 to square root 2 over 9. And 2 square root 2 over 3, I mean, because this is 3. Yeah. Okay. Or 2/3 square root 2. Yeah. So y, okay, y equals as you know, y equals a sine omega t. Okay, it means 0.06, 0.06 because 6 centimeters convert into meters. Okay, sine square root 2 over 3. Yeah, sine omega t is 1 square root. This, yeah, sine omega t root third. Yeah, and if we calculate through calculator, we can find 0. Let me calculate 0.0. 3 times 2, 3 times 0.06. Yeah, 0.56. Yeah, 0.56, 0.0, 0.056 or 0.606. Yeah. Yes. Yeah. And 6. Okay. An object of mass 0.25 kg performs oscillations with a period 0.2 seconds and an amplitude of A equals 5 times 10 power negative 2 meters when the deviation is y equals 2 times 10 power negative 2 meters. Calculate acceleration of the object, restoring force, potential energy, and the kinetic energy of the object. Okay, so for A, yeah, I'm going to identify first that M 0.25. What else? A 5 times 10 power negative 2. Okay. Uh, meters, amplitude in meters. Y equals 2 times, this one, 2 times 10 power negative 2 meters, 12. Okay. Hmm. And now I'm going to find period. So the period 2 pi, sorry, pi times square root m over k. So it becomes, yeah, I'm going to find k. So I have to create k becomes the subject. If k the subject, it's gonna be, wait, uh, square root m over k equals t over 2 pi. Okay. So k equals okay, 2 pi over t squared times m. Yeah. And k equals 2 pi, it means 4 pi squared. Okay, 4 pi squared over t squared. Yeah. Times m. Oh, t, this one, this one, t, already 0.2 seconds. Okay, 0.2 second. That means 0.2 squared. Okay, 0.2 squared times m 0.25. And then we calculate 4 pi over 0.04. Okay, 4 pi is 0.04 times 0.25. If we calculate, becomes 25. Okay, sorry, 25. Okay, pi, 25 pi squared. Newton. Okay, Newton per meters. That is K. And then for after that, yeah. Accelerations, we are going to calculate, but we have to, okay, we have to find omega first. Bring omega. Square root of k over m. Then square root 25 pi squared. M is 0.25. Okay, equals 100. Means 10 pi. Okay. And yeah, for omega, the unit radian per second. Radian per second. And then after that, A, because we are going to find the acceleration. So A equals minus omega squared y As in omega equals negative equals 10 minus 10 pi squared. Okay. And y equals, just now y is what? 2 times 10 power negative 2. Okay. Okay. And if we calculate, we can find the solution, the calculation negative 2 pi squared meter per second squared. Okay, that's A.